Systems of linear inequalities. Student learning objectives. Graph systems of linear inequalities in two variables. Graph systems of linear inequalities in two variables. For a system of linear inequalities in two variables, the solution is the shaded region where both inequalities in the system intersect. So here we have a system of inequalities in two variables. Now we have a system of inequalities. So there are in two variables, so two inequalities and two variables. And to graph each inequality in the system, we first graph each inequality in the system. 2, the shaded region where both inequalities intersect is the solution to the system of linear inequalities in two variables. So let's graph these two inequalities. So the first thing is graph the inequality. So we graph the equation x plus y is equal to 5. X-intercept is when y is 0, which is 5, 0. The y-intercept is when x is 0, y is 5. For the second inequality, we're going to graph the equation minus x plus y is equal to minus 5. For this, the x-intercept is when y is 0, x is 5. The y-intercept, when x is 0, y is negative 5. So we have two ordered pairs for each of these equations. So now we can graph each line. Let's say this is 5, this is 5, minus 5, and minus 5. The x-intercept for the first one is 5, 0. Y-intercept 0, 5. Then since it's less than, the inequality is, the line is going to be dashed line. And this line here is x plus y equal to 5. Then pick a test point. So for the first equation here, for the first inequality here, the test point that we pick is the origin. We pick the origin, 0, 0. When we plug in 0 for x and 0 for y, we get 0 less than 5. This is a true statement. So that means we shade this side of the region for this line. Let's graph minus x plus y equal to negative 5. Since it's greater than, the line is going to be dashed line. So the x-intercept is 5, 0. The y-intercept is 0, negative 5. So we plug in 0, negative 5, 0, negative 5, and 5, 0. So these are the 2 points we have on the line. We connect the lines and extend the line beyond. So it has to be it cannot be a solid line since it's greater than. So it has to be dashed line. Okay, so this equation, this line is minus x plus y equal to minus 5. We can pick the test point again, 0, 0 for the second line. Test point here is 0, 0. The line doesn't pass through the point 0, 0, the origin, so we can make it 0, 0 a test point. If a point on the line cannot be a test point. Okay, so we plug in 0 for negative for x, we get and y 0. We get the statement 0 is greater than negative 5. This is a true statement. This here is true statement. 0 is greater than negative 5. So for this line, we shade this region. So the regions where the two shaded regions intersect for the lines is this region here. So we shade, this is the region that we shade. This is the solution. If we shade for the first line, this is the arrow indicates the side of the plane that we shade. So we would have shaded this here for it. And then for the second line, this arrow here is what shows the region that the side of the plane that we shade. So we would have shaded this region like this. And the two shaded region that intersect is where we have the marker, the purple marker. So that will be the region where the two intersect. So just to remove details, we didn't put it here. So the region where both intersect is this region here. This will be the region that we would shade.